Okay, so even though we asked the computer to solve it, I did want to show how to find these possible inflection points by solving algebraically. Negative 2a times x squared plus b squared minus negative 2ax times 4x cubed plus 4xb is equal to 0. So first, let's notice we can factor out this negative 2a from everything and rewrite this as negative 2a times x squared plus b quantity squared minus x, and this is just a positive x now, because I factored out this negative, times 4x cubed plus 4xb is equal to 0. Now by the zero product property, I can split this out. Either negative 2a is 0, or this whole expression is equal to 0. So I have negative 2a is equal to 0, or x squared plus b quantity squared minus x times 4x to the fourth plus 4xb is equal to 0. Now I need to do two things. I need to expand x squared plus b quantity squared, and I need to distribute the x to 4. This should still be 4x to the third, my apologies. It's 4x to the third plus 4x. When I expand this, I get x to the fourth plus 2x squared b plus b squared minus 4x to the fourth plus 4x squared b. And all of this is still equal to 0. Now I need to simplify this by distributing this minus through. So I get x to the fourth plus 2x squared b plus b squared minus 4x to the fourth minus 4x squared b equals 0. And I can combine like terms. So I have an x to the fourth and a minus 4x to the fourth. And I have a 2x squared b and a minus 4x squared b. And now I have negative 3x to the fourth minus 2x squared b plus b squared is equal to 0. And I would like to multiply both sides by -1 because I like to have a leading term here. So -1 times everything over here becomes 3x to the fourth plus 2x squared b minus b squared is equal to 0. Now this is what's called a quadratic in form, because if I let w equal x squared, I could rewrite this as 3w squared plus 2bw minus b squared is equal to 0. So now the question is, can I rewrite this in the form where it's factored? I want to factor this. Factor this, what I'm going to have is 3w and w and plus or minus things. So I'm going to have w plus b, and here I'm going to have 3w minus b. Now this is still equal to 0. So either I have 3w, now let's verify first that that actually gives me back what I wanted. 3w times w is 3w squared minus bw plus 3bw minus b squared is equal to 0. So if I did factor this out because it re-expands to be what it was here. So now I am trying to solve 3w minus b times w plus b is equal to 0. 3w minus b is equal to 0, or w plus b is equal to 0, which gives me 3w equals b, w equals negative b. So w equals b over 3, or w equals negative b. Well, wait, what was w? W was a substitution I made a minute ago, where I made a new variable and said w is equal to x squared. So this was something I subbed in here. Look at that and say, actually, this becomes in terms of x, either x squared is equal to b over 3, or x squared is equal to negative b. In which case, what I'm seeing here is x equals plus or minus the square root of b over 3, or x equals plus or minus the square root of negative b. In this class, we won't worry about this. So our only two solutions would be x equals plus or minus square root of b over 3. That's exactly what the computer found when we asked Wolfram Alpha to solve it. If you look at the answers that it got, these answers are equivalent to the answers that we found when we solved it by hand.